So this is the first example. Even though it is a two variables y and x, but I didn't give the procedure y and x, but I want to express y is equal to in terms of x. E power y is equal to x raised to 1 by x. Taking logarithms log on both sides. Bs stands for both sides. So this becomes y log e is equal to 1 by x into log x. Logarithm properties. Log e to the base e value 1. Y is equal to log x divided by x. Y is nothing but a function of single variable x. Now this problem completely becomes in terms of single variable x term. Okay. So what is the procedure? F dash x. U by v rule, quotient rule. X into log x derivative 1 by x minus log x into x derivative with respect to x1 divided by x square. Next, after finding first derivative, equate to 0. That means numerator equal to 0. Numerator simplifies 1 minus log x equal to 0. That means this is 1 minus log x by x square. So satisfying x is equal to e only. Okay, x is equal to e. E is the STPT. Short form I am writing. STPT means stationary point. The points x obtained from f dash x equal to 0 are called stationary points. Now after these stationary points you find second derivative. Again applying u by v rule for first derivative. X square into 1 minus log x derivative minus 1 by x minus of 1 minus log x into x square derivative with respect to x is 2x divided by v square. Look at the quotient rule derivative formula, x square whole square. So now substitute this first one stationary point at x is equal to e. At x is equal to e, what is f double dash x? This simplifies to minus e, logarithm e value 1, 1 minus 1 value 0 divided by e raised to 4. This simplifies to minus 1 by e cube, which is always less than 0, as e approximately equal to 2.71. So therefore second derivative less than 0 means f of x has maximum value at x is equal to e. So accordingly the option is A. But I am finding the maximum value, and the maximum value is how to find this maximum value is substitute this e point in the function, that is f of e is equal to e raised to 1 by e to the power 1 by e. So once we decide a point is maximum or minimum, how to find the value, maximum value or minimum value, substitute that corresponding x value in the function value. Once you decide a value x, a point x is either maximum or minimum, then put the point in the function value which gives the corresponding maximum value or minimum value. Copy down. So in this, using this procedure, I am giving you 1 or 2 problems with answer also. Try later. Second one, this is given 2007 2 marks for real x, comma, the maximum value of e power sin x divided by e power cos x is So just I am giving this problem, later you do one hint, first step hint along with answer also. So if you take the given function as denoted by f of x, if you apply while finding f dash x, if you go by directly u by v, it takes more number of steps, that is the problem becomes laborious, that means the problem becomes lengthy and takes more time also. So in such cases just apply indices formulas, a raised to m divided by a raised to n, that is nothing but, okay. After that I am giving this answer e raised to root 2, e power root 2, later you check maximum value. One more problem I am giving, later you do. 2005 2 marks. In the domain minus infinity less than x less than infinity, comma, the function instead of y of x, f of x, it is given y of x, x cube e power minus x has options: 1 maximum and 1 minimum, 1 maximum and no minimum, 1 minimum and no maximum, neither maximum nor minimum. Answer is 1 maximum and no minimum. Later you check. Now I am giving the procedure for 2 variables. Procedure for finding absolute maximum, absolute minimum of fx in a closed interval a comma b. Whenever interval is given, closed interval, then that maximum minimum indicates absolute maximum, absolute minimum. Let fx be differentiable in closed interval a comma b except at a finite points. Except in bracket possibly. Step 1. Evaluate f of x at the points x where f dash x equal to 0, comma, f dash x does not exist. Step 2. Evaluate fx at the endpoints at x is equal to a and b. Then the maximum of these values is called the absolute maximum of the given function f and minimum of these values is called absolute minimum of the given function f. So just I am giving a note point. Sometimes in closed interval AB the question also requires local maximum. Let f dash c is equal to 0 where a less than c less than b, that is c lies between a and b. Full stop. If f double dash c less than 0, then f of x has local maximum at x is equal to c. If f double dash c greater than 0, then fx has local minimum at x equals. First write down, and then if possible, if you understand, then by heart that procedure. Now see, evaluate fx at the points x where f dash x equal to 0. That means this step has done already in the previous problem. Find f dash x equal to 0, find the corresponding x values. At that x values, find the function value. And similarly, you find an x value where f dash x does not exist. You find x values where f dash x does not exist. At that x values also you evaluate fx. Step 2, at x is equal to ab, endpoints of the closed interval, given interval, you find fx values. So in these two steps you are getting some fx values. The maximum of these values is called absolute maximum, and the minimum of these values is called absolute minimum. So note point, whenever you get f dash is equal to 0, that means the points where f dash x equal to 0, the points x where f dash x equal to 0, such x value lies between a and b denoted by c. Okay, find f dash x equal to 0, solve f dash x equal to 0, you will be getting some x values, and in that some x values may lies between a and b. Okay, so that point is denoted by c. At that c, if second derivative less than 0, then it has local maximum. If second derivative greater than 0, then that function has local minimum at x equal to c. Please by heart. So here one more condition, just I am underlining. You have to find the points x where f dash x, after calculating f dash x, see that does not exist at some value of x, or it is exist at every value of x. You find an x value where f dash x does not exist. For example, in some problem if you get f dash x equal to 1 by x, then where it does not exist at x equal to 0, and see that points is in the interval or not. Okay, interval is given, closed interval a comma b. So one problem is given, 2012. The maximum value of fx is equal to x cube minus 9x square plus 24x plus 5 in the interval 1 comma 6 comma is A 21, B 25, C 41, D 46. Solution. Here interval, closed interval is given. So problems defined in closed interval, problems without interval also. There are two types of maximum minimum procedures, one variable only. Fx is equal to x cube minus 9x square plus 24x plus 5. Okay. A is equal to 1, B is equal to 6. Anyhow, first step, finding f dash x. 3x square minus 18x plus 24. So f dash x equal to 0. That means 3 is common, send into right side, which simplifies to x square minus 6x plus 8 is equal to 0. Solving this equation, we will be getting 2 comma 4. Okay. Now what is step 1 is given? Evaluate fx at the points where f dash x equal to 0. And here f dash x exists. There is no does not exist concept here. Everywhere polynomial function it is exist everywhere in closed interval 1 comma 6. Okay, step 1, find f of 2. I told you what is step 1. Evaluate fx value at the points x where f dash x equal to 0 and f dash x does not exist. So we got only 2 4. Okay, and 2 4 there belongs to 1 comma 6. Okay, f of 2. Substitute 2. 8 minus 36 plus 48 plus 5. That is, this simplifies to 25. F of 4. 4 cube 64. 9 into 16 144 and 96 plus 5 and 100 160. 16 plus 5. This simplifies to 21. What is step 2? Evaluate FA and FB. F1 is equal to 1 minus 9 plus 24 plus 5. This gives to 21. F of 6. 6 cube 260, 9 into 36 270 and 54 simplifies to 324 plus 144 plus 5. So this simplifies to 41. So of all these 2 steps, which is maximum 41, therefore f of x has maximum, that is in bracket absolute value 41 at 2, x is equal to 6. Of all these, which is minimum? This is 2 values, 21. Okay, so note first point. In the above, comma, f of x has minimum absolute value, how much? 21 at x is equal to, where it occurs, at x is equal to 4 and x is equal to 1 and 4. So we have decided absolute maximum, absolute minimum, that is maximum value, minimum value, even though minimum value is not required, but I am proving all these things. Second note point. Now let us check if there is any local maximum at some point or minimum like that. Okay, here C is equal to 2 comma 4 as 1 less than C less than 6. 1 value A given endpoints of the closed interval, 6 is B. 2 4 we got from f dash x equal to 0. So in this case, find f double dash x for deciding that local maximum, local minimum. F double dash x is 6x minus 18. Okay, what is f double dash 2 minus 6 less than 0, and what is f double dash 4 plus 6 greater than 0. Therefore f of x has local maximum at x is equal to 2 and local minimum at x is equal to 4. Just see. Just look at that previous discussion what I have given, one by one note point and one by one step like that. Up to this 41 problem is over, but I have discussed other cases also according to my notes. I mean accordingly what I gave the definitions and note point. Please check. With this, one more example I am giving. Which is asked in 2012 in one branch. Consider fx is equal to sin x in pi by 4 comma 7 pi by 4 full stop. The number and location, yes, location or locations of the local minimum of this function are options 1 comma at pi by 2, B 1 comma at 3 pi by 2, C 2 comma at pi by 2 and 3 pi by 2, option D 2 comma at pi by 4 and 3 pi by 2. Just see. Answer is option B. Number and location means find f dash x equal to 0. Find x values and see that x values according to this. Okay. At each x value, location means the number of the value of x where it is going to local minimum. I have given local maxima, minima, absolute maxima, absolute minima in the previous problem in a closed interval. So whenever local maximum minimum required in closed interval, that means you go for directly second derivative and find second derivative at the points C lies between the end points A and B. I have given that note point and the previous problem procedure. Okay. Answer is one number and that location is 3 pi by 2. At 3 pi by 2 it is going to become local minimum. And remember at the end points, local maxima minima never occur at end points. Absolute maxima minima can occur at any point in the interval, either in extreme points or either at the end points or between the end points also. Absolute maximum can occur at any place, but local maxima minima cannot occur at the end points. Okay. Just remember the points where f dash x equal to 0 are called stationary points. The points x where f of x has maximum and minimum, that is called extreme points. The points x where f dash x equal to 0 and f dash x does not exist, that is called critical numbers or critical points. Okay. Stationary points, extreme points, critical numbers. The points where f dash x equal to 0 or f dash x does not exist, that points are called critical numbers or critical points. Please remember. Procedure for finding maximum / minimum for a function of two variables x comma y, that is f of x comma y. Step 1. Find del f by del x, which is also denoted by small p, which I have given yesterday, that notation. Del f by del y, which is also denoted by q. Step 2. Solve p is equal to 0, say equation 1, and q is equal to 0, say equation 2. Let a1 b1, a2 b2, so on, are called the stationary points obtained from 1 and 2. Step 3. Find del square f by del x square denoted by r, del square f by del x del y denoted by s, del square f by del y square denoted by t at these points a1 b1, a2 b2, etc. Take the first point at a1 b1 comma first condition, just like one variable extension, these two variable. If r less than 0 and rt minus s square greater than 0, then f of x comma y has maximum value at a1 b1. If r greater than 0 and rt minus s square greater than 0, then f has minimum value at a1 b1. 3. If rt minus s square less than 0, then f has neither maximum nor minimum at a1 b1. If rt minus s square is equal to 0, then no conclusion can be drawn about maximum or minimum. And it requires further investigation. Copy down. So just like extension to one variable, here two partial derivatives, one is with respect to x, other is with respect to y. Yesterday I have given notation PQ. Similarly, find second order derivatives also with respect to x 2 times, x and y 2 times, denoted by RST. So what I have given procedure for one variable, after first derivative we have taken 0, equated to 0, and we solve that equation. We got some x values which are called stationary points. Here solving two equations, you will be getting x and y values, collecting like this pairwise, a1, b1, a2, b2, they are called stationary points obtained from these two equations. Okay, and I told you whatever the points you will be getting, that is always satisfying the given equations at a time. What are given equations? First order derivative is equal to 0. Suppose if you get x is equal to 1, 2, 3, and these values should satisfy the first derivative equal to 0. Similarly, in partial derivatives, in this method, whenever you get some x 1, 2, 2, 3 points, 2D points, they should satisfy both p is equal to 0 and q is equal to 0. Then only you consider that as a stationary point. Okay. Next, once you find that second derivatives at each point, come to the step 4, just like in one variable procedure. If r less than 0, rt minus s square greater than 0, please by heart this condition. Then this is maximum value. R greater than 0 and rt minus s square greater than 0, minimum value. If rt minus s square less than 0, neither maximum nor minimum. If rt minus s square is equal to 0, no conclusion can be drawn about maximum. It requires further investigation. That means due to assumption for some positive values of x and y. Okay, then we can decide the nature. It is a lengthy procedure. That is 8 marks question. Whenever we get a point rt minus s square is equal to 0, that is okay. Next. So whenever a point here neither maximum nor minimum, that point is called saddle point. Okay. Just adding. In this case, a1 comma b1, I am adding here, is called, please add in the third condition, the point a1 b1 is called saddle point. That is the function where it is neither maximum nor minimum in 2D case, I mean in two variable functions. All of you please add this point, and those who are completed to write these things by heart, the steps, procedures. Example which is given 2002, 2 marks. The function f of x comma y is equal to 2x square plus 2xy minus y cube has options. A. Only one STPT, stands for stationary point, at 0, 0. Option B. Two stationary points 0, 0 and 1 by 6, minus 1 by 3. Option C. Two stationary points at 0, 0 and 1 minus 1. Option D. No stationary point. Just here we calculate the first order derivatives and equate to 0 and solve that equations and find the corresponding x values. We need to find only stationary points, that is up to first order derivatives, not required to decide that nature, that is not required to find second order derivatives in this problem. But even though I I will decide after getting the points the nature of that point. Nature means either maximum or minimum or neither maximum nor minimum. See, solution. F is equal to 2x square plus 2xy minus y cube. First find partial derivatives. Del f by del x denoted by p is equal to partial with respect to x means y constant. So 4x, here y constant, 2x derivative 2, 2 into y cube derivative 0. And del f by del y partially with respect to y means keeping x constant. Now this is denoted by q. With respect to y means 2x square 0, x constant, 2 into y derivative 2, so it simplifies to 2x, and y cube derivative with respect to y is 3y square. Okay, now equate to 0. P is equal to 0 implies take common 2, 2x plus y is equal to 0, let us say equation 1, and q is equal to 0, which implies 2x minus 3y square, nothing simplification in this equation 2. So you have to get x and y values after solving. That means you find x and y, x comma y values, stationary points. That means solving these two. So solving these equations means if it is difficult to solve, then you try to get a third equation which containing only one variable. That means using from one of these equations find y or x and substitute that value in another equation, so that you will be getting a third equation containing only one variable. Then only it is solvable. Okay. See, we know adding, subtracting, all these procedures solving. Okay. But here it is all first degree and it is different degrees. So in such cases you get you should get a third equation which containing only one variable. So from 1 I can write y is equal to minus 2x. Okay. So therefore 2 implies, substitute this y value in this, 2x minus or you can write directly here, minus 2x is equal to y means 2x is equal to minus y minus 3y square is equal to 0. Instead of substituting here y, I substituted 2x is equal to minus y. So minus y is common, 1 plus 3y is equal to 0, which implies y values 0 minus 1 by 3. Now substitute 1 by 1 y value in the latest equation, that is, say all of you, this is equation 3. This is a new relation equation between y and x, where y is equal to in terms of x. From 3, you will be getting 1 by 1 x values after substituting these 1 by 1 y values. So x is equal to 0 and minus 1 by 3 to minus 2 is 1 by 6. So collecting pairwise, therefore 0 comma 0 and 1 by 6 comma minus 1 by 3. We got only 2 stationary points or 2 stationary points. So what is the answer? Option is B. But in this problem I am going to do further, that is to decide the nature of each point, note, after making a note point. In the above problem, see all of you, R is nothing but del square f by del x square. That is, for del f by del x you find one more derivative with respect to x, gives 4. Yes, nothing but del square f by del x del y. That is, for del f by del y you find with respect to x, which gives 2, and t is equal to del square f by del y square. That means for this you find one more derivative with respect to y, which gives this 0, and this is minus 6y. That means I have calculated all the second order derivatives denoted by RST. Okay. So, or you can write directly like this for understanding purpose, other notations. Okay. Now what is the next step? Take first 1 by 1 point. At first point, what is the first point? 0, 0. Calculate, substitute all the second order derivatives, this point in all the second order derivatives, and go to your 1 by 1 conditions in step 4. R is equal to how much? 4. S is equal to, already they are constants, T is equal to 0. And RT minus S square. What is RT minus S square? 0 minus 2 square, that is minus 4, which is less than 0. That is, therefore, F is neither maximum, look at your notes, That means what I gave the steps, neither maximum nor minimum at 0 comma 0. What is second point? At 1 by 6 comma minus 1 by 3. For this point, what is R? Substitute in all the three derivatives. This point 4, S is equal to 2, comma T is equal to minus 6, minus 6y, minus 6 into minus 1 by 3, this becomes 2, implies RT minus S square, how much? 4 into 2, 8 minus 2 square, 4 greater than 0. Whenever RT minus S square greater than 0, there are two cases for R. Here, R greater than 0. Therefore, F is minimum at 1 by 6 comma minus 1 by 3. And the minimum value is, how to find the corresponding minimum value? Substitute this point in the given function. What is given function? F of x comma y, where x is equal to 1 by 6, y is 1 by 3. Later you calculate that minimum value after putting x is equal to 1 by 6 minus 1 by 3 is equal to y in the given function. After putting x is equal to 1 by 6 and y is equal to minus 1 by 3 in the given function, we get the corresponding minimum value. Just like one variable procedure extension only. Look at your notes. Look at that one by one stepwise in step 4 I have written here. Though it is not required, but for understanding purpose, how to find the nature. Okay, actually by this problem this step is over. To decide the stationary points only. That means to find the stationary points only. But I have decided the nature. So with this I am giving one more problem based on this. Later you do. Second example on this model. Which is given 2010, 2 marks. Consider f of x comma y is equal to 4x square 6y square minus 8x minus 4y plus 8, comma the optimal values of f of x comma y is options: a minimum equal to 10 by 3, B, option B, a maximum equal to 10 by 3, option C, a minimum equal to 8 by 3, option D, a maximum equal to 8 by 3. So here optimal values means other name for extreme values, minimum maximum. Optimum means either maximum or minimum. Okay. Answer is option A. Later you check. I have decided like this: minimum value. You need to find minimum value. That value is 10 by 3. In this problem, I left to you to calculate that value, f of 1 by 6 minus 1 by 3. That means in the given function, substitute x is equal to 1 by 6, y is equal to minus 1 by 3. The value so obtained is called minimum value. As above, that means using this procedure, you do this problem. Optimal value means here one of the option is given, a minimum equal to 10 by 3. Whatever the stationary points you will be getting, whatever the stationary points you get in one of these points, the minimum value equal to 10 by 3, that you have to show. Next, evaluation of definite and improper integrals. That is the last topic in calculus, differential integral calculus. In this, statement 1 is fundamental theorem of integral calculus. Let f of x be continuous function in closed interval a comma b, and capital F of x be any antiderivative, that is integral of fx in closed interval a comma b, in brackets, that is integral f of x dx equal to capital Fx plus c. So then integral a to b f of x dx is equal to capital F of b minus capital F of a. So this term is called definite integral. A is lower limit and b is upper limit, and this term is called indefinite integral. So in 11th and 12th standard we have studied definite integral, indefinite integral. Whenever the limits are there, that is called definite value. Whenever the limits are not there, that is called indefinite value, that is coming by plus c. C is constant of integration. So here the term going to integrable, that is called integrand fx, should be continuous in the given interval, okay, at a, at b, between a and b. Then this value is obtained by fb minus fa. What is capital Fx? Is any integral, that is also called antiderivative, that is I have written in the brackets, integral small fx dx equal to capital Fx. So capital Fx is the integral of small fx, and small fx is nothing but the derivative of capital Fx, okay. So just see one example, integral x cube 0 to 1. So what is the procedure here? Capital F of 1 minus capital F of 0. Okay. Here, what is capital Fx? Integral small fx, x cube dx. This x cube is small fx. What is x cube integration? X power 4 by 4 plus c. Okay. So this is our small fx. Now what is the answer? In that capital Fx, substitute c cancelled. You will be getting 1 by 4 minus 0. 1 by 4. C is constant of integration. A is equal to 0, B is equal to 1, lower limit, upper limit. Just this procedure. If you remember the normal ordinary integrations without limits, then you substitute after integrating upper limit and then put minus and then substitute lower limit. That is called first fundamental theorem of integral calculus, that is definite integral. Okay. So next I will discuss properties, that is evaluation of definite integrals using some properties. Okay. So this is the fundamental theorem of integral calculus, tells the procedure of evaluation of definite integral, where small fx is the derivative of capital Fx is any integral of small fx, that is integral, other name is antiderivative. A is lower limit, B is upper limit, that I have shown you in the procedure. Okay, this is indefinite integral procedure, this is definite integral procedure for the same small fx x cube.